Hello learners, this is Education Online program. Our subject is chemistry and the topic is reactivity in group 7 elements, and this topic is for senior 3 and 4, and I'm teacher Lily going to present for you this topic. So if we talk of reactivity in group 7, we are talking of their reaction with other reagents. So we know the group 7 elements, they are fluorine, bromine, chlorine, iodine, astatine. So it means there are 5 elements in group 7. So here we're going to say that group 7 which are considered to be halogens. So halogens here, they are salt formers, and these halogens, they are fluorine, chlorine, bromine, iodine, and astatine. So in this case, you need to remember that the last one is a radioactive element, and a radioactive element is treated separately from the rest of the elements. And we know that the other elements are non-metals, and they react in the same way, or we treat them together. So in this case, we have the first element is more reactive, and the last element is less reactive. So we have to say that fluorine is highly reactive, and iodine is the least reactive. So least reactive element is halogen. So they are all non-metals. Their reactivity decreases as we go down the group. So that is why we put here that fluorine is highly reactive, while iodine is the least reactive. So if fluorine is the highly reactive, it means some of the reaction will be difficult to control. So in this case, we only deal with the 3 elements, which is chlorine, bromine, and iodine in their reactions. So in this case, when you have the reaction of halogen with the metal ion, so the first reaction is the reaction of one of the halogens with ion, with the ion or metal ion. So here in this 4, we say that metal ion, here we write its symbol as Fe. So the metal ion here, when it reacted with one of the halogen, we need to remember that the most highly reactive elements are those above, and the least reactive are those below. So below where? Below in the group 7. So we are going to have that the ion will continues to burn and react with the chlorine, producing brown fume. So we are going to have ion wool, and this is representing ion wool. So ion wool here, when it burns and react with the chlorine, when it burns and reacted with chlorine, so in this case we are going to have it as a gas. So chlorine here will be as a gas, and it is going to react with the ion wool that has burned, and then its smoke will be reacting with chlorine gas. So we shall have chlorine. So when it reacted with the chlorine, this produces brown fume. So it produces brown fume. So here, when you have the reaction of bromine with the ion wool, it gives us a brown fume. So this brown fume of ion 3 chloride, we are going to have it as ion 3 chloride. So ion 3 chloride is in form of a brown fume. So when you have reacted or joined ion with the chlorine, it will give us ion 3 chloride. In this case, there is a changing of the ion from ion to ion 3. So in this case, we are going to have the brown fume condenses on the cooler part of the delivery tube. So of course, when you're doing your reaction, you need to have a vessel, a reaction vessel, and either it can be a flask or it can be a beaker. And here we are going to have this brown fume, which is ion 3 chloride. It will be where it will be condensing on the cooler part of the delivery tube. So there is usually a delivery tube whereby you have the products going into. So this will condense at the walls of the delivery tube or the cooler part of the delivery tube to form red brown crystals. So we are going to have this ion 3 chloride will turn, it will form a brown crystal. It will form a brown crystal, and here we are going to have it as red brown crystals. So we are going to have it as red brown crystal. So it means here it is going to form a crystal, and this crystals is going to be in brown color, which is red brown color. And in this case, you need to remember that it was this ion 3 chloride that has a stick into the wall of the delivery tube, and it condenses and form a crystal, and the crystals turn to be red brown. So we are going to have an equation to show this reaction. We are going to have fluorine, two molecules of fluorine, two molecules of iodine, of iron, which is in solid form because it is a metal, plus 2 molecules of chlorine gas. It will give us this product, which is a fume, and this fume is in solid form. So this produces ion 3 chloride, which is brown fume, which turn to form red brown crystal, and when it is stick at the wall of the delivery tube. So we are going to have hot iron wool. So when you have iron wool here, this can be cold, and when you have hot iron wool, hot iron wool to react with bromine vapor to form red crystals of ion 3 bromide. So in this case, when you have it as hot, why do we have it as hot iron wool? Remember, the reactivity decreases as we go down the group. So it means this iron wool should have to be hot, at least for the reaction to proceed with iodine. So with the bromine. So in this case, we have hot iron wool with reacting with bromine vapor. So it means that is bromine being kept into another container, and its vapor is the one reacting with iron or hot iron wool. So this will form iron. This will form red crystals. To form red crystals of iron 3 bromide. So the reaction is not vigorous. Why? Because we know that bromine is less reactive compared to chlorine. So here it's less vigorous as the one with the chlorine, and you can predict the reactivity of iron with iodine to be the least reactive. So in this case, if we have bromine reacting less vigorously with the iron wool, what will be for iodine? It means for iodine the reaction may not proceed. Why? Because iodine is the least reactive in the group. So in this case, we shall have iron plus bromine. So here we are going to see that iron and bromine, they are representing the reagents, and here we say that this is iron wool, and the reaction will look like this: 2 bromic and here it is a solid, and this is having a crystal which is red in color. So in this case we shall have iron reacting with the bromine molecules to give us iron 3 bromide. So iron 3 bromide is a crystal, that is why we indicate it with the S, and it is representing a solid. Here we have a gas of bromine. So in this case we are going to see that iron with the bromine will give us iron 3 bromide, which is crystal form, and the crystal is red in color, while the one of iron 3 chloride is the crystal is red brown in color. So this is the crystal that is stick at the wall of the delivery tube, the cooler part of the delivery tube, and you will see that there is red brown crystal. So it means that is iron 3 chloride, while here we have iron 3 bromide, which is red in color. So in this case we have seen that as you have fluorine iodine with the iron, the reaction will proceed in a very slow way. Why? Because iodine is the least reactive, and it will give us this product, which is iron 2 iodide. So it will not be iron 3 as we have for bromine, or iron 3 as we have for chloride. So in this case we are going to have it as iron 2 iodide. So in this form, because we have iodine is the least reactive, and its reaction will not be vigorous as the rest of the elements reacting together. So it is here we are going to see that iron has been oxidized to iron 2, unlike bromine and chlorine that oxidize iron to iron 3. So we are going to see that iron has been oxidized to iron 2. So what happened in the first one? We have iron has to be oxidized from iron 2 to iron 3. That is why you have iron 3 chloride, iron 3 bromide, and for the case of iodine, because its reaction is not vigorous, or it is less vigorous than the rest of the elements, and it changes iron 1 to iron 2. So learners, we also need to know the displacement reaction of the halogens. Here we're going to see the displacement reaction of the halogen. So if you say displacement, it means we are talking of the other atom is taking place of the other one. So this is known as the reactivity series. So there is a series for the reaction of these halogens. We will see that those above are more reactive than those below. It means they will take the part of those ones which are below. So a strong one will take the part of the weak one. So we are going to see that the halogens will displace the one below in the group from its halide solution. So a halogen, halogen displacement reaction, or let me say displacement reaction of halogen. Displacement reaction of halogens. So the displacement reaction of halogens depends on the reactivity series of the halogen. A halogen will displace one halogen displaces, or it will take the place of the other halogen which is less reactive. So displaces the one below in the series. Displaces the one below in the reactivity series. So in this case we need to remember that fluorine will displace iodine, and it is also displacing fluorine, bromine, and also it displaces what? Chlorine. So those below in the group, let me say from fluorine to iodine, so we shall have fluorine is the highly reactive one, and it displaces it displaces chlorine, and chlorine displaces bromine, bromine displaces iodine. So but we can see that fluorine, which is the first in the group, it displaces chlorine, bromine and iodine. So chlorine will have the ability to displace bromine and iodine, while bromine will only displace iodine, but iodine cannot displace the rest of the elements from their halide compound. So in this case, we are going to have that fluorine will displace chlorine and so on, their halide solution. So while bromine displaces iodine from its aqueous solution. So in this, we are going to represent it in this way. Fluorine gas, which is a diatomic molecule, then it plus halide solution of chloride. It means it may have potassium or sodium combining together to form an aqueous solution, and here we shall have fluorine. With this, will give us fluorine will take the place of chlorine. So we shall have fluoride ion with one of the metals, and here we shall have plus chlorine, which is displaced from its compound. So we shall have chlorine atom put separately. So in this case, we are going to see that fluorine has displaced chlorine from its halide compound or solution. So we can have also chlorine molecules. It will displace bromine, which is in a compound form, and here we are going to have that chlorine, because it is higher in the reactivity series, it will displace bromine. So we shall have chlorine plus bromine atom. So in this case, we are going to have the gas here, and these are aqueous solutions. So learners, you have seen how this reaction actually takes place. We have fluorine gas. It displaces chloride ion. Why? Because chloride comes after fluorine. And here we have chlorine gas will displace bromide from its compound. Why? Because bromide comes after chlorine. The same thing also, fluorine can displace bromine because it is under bromine in the reactivity series. So also the same thing will happen with the bromine, with the iodine, and as we go down the group. So remember that the reactivity series decreases as we move down the group. So those below are having a lower reactivity, and they are displaced with the one having higher reactivity. So this is known as the displacement reaction of the halogens. So the displacement reaction of the halogens here, it shows that the reaction has to be in this way, as we have seen that the least reactive is displaced from its compound, as we have seen for fluorine, reacting with the chloride compound, and then fluorine will take the place of the chloride. So in this case, we have it also with the bromine. We have it with the bromine plus iodine or iodide aqueous solution. It will give us iodide aqueous solution. It will be bromine plus iodine aqueous. So in this case, we have seen how we displace the displacement reaction goes. So as we have put here very clearly that fluorine will displace the 3 atoms, chlorine will displace the 2 atoms, and bromine will displace only iodine, but iodine cannot displace the 3 elements. So you are going to see also an example for this. We are going to have bromine, potassium chloride. Potassium chloride, this is an aqueous solution of potassium, and here when you react it with the bromine, what will happen, learners? Will say that there is no reaction being observed. So we shall have plus bromine. We will say that no reaction. Why? Because bromine is less reactive compared to chlorine. But if we have potassium bromide plus chlorine gas, this automatically we are going to see that there is displacement reaction that will take place. So we shall have potassium fluoride and plus bromide gas. So in this case we have an aqueous solution of potassium fluoride form because fluorine can displace bromine from its compound. So we have here as a gas, and here we have seen this, and also we can have sodium chloride plus fluoride. It will give us what? Because we have seen that fluorine is after what? Chlorine is after fluorine. So in this case, fluorine has to take the place of chlorine in this reaction. So we shall have it as the salt of sodium chloride. Then will give us sodium fluoride salt. So plus chloride gas. So learners, you have seen these examples, and it is showing clearly how does the displacement reaction here happens. So the displacement reaction, it is so that the reactivity series decreases, or the reactivity decreases as we move down the group. And in the reactivity series, fluorine comes before the three elements, which are bromine, chlorine, or iodines. So in this case, we have seen these examples, and it is showing clearly that this reaction, that is displacement of those which are least reactive in, or those below in the reactivity series. So we have also to see that chlorine water, we can have chlorine water as we go to this reaction. We are going to see that there are some other observations that we will see. Chlorine water, which is in liquid form, and we can say that chloride water. So here this chloride in aqueous form, because it is water, it is colorless. So if this reacted with the potassium chloride, so if you have potassium chloride, which is also colorless, learners, what will happen to this reaction? We are going to see that there is no reaction that will take place. Why? Because we have the same atoms here. We have the same elements, which is chlorine and chlorine. So the displacement reaction will not happen. So if you have chlorine with potassium bromide chloride solution, which is colorless, with the potassium bromide, and here this potassium bromide, when it reacted with chlorine, it will form an orange solution. It means the reaction has taken place, and this orange solution will be formed. So the orange solution will be formed. So the orange solution is formed. So in this case, we say that the reaction has taken place, not like here whereby there is no reaction. So we have seen this, and also we have to remember that whenever you have a reaction that has not occurred, there must be any other reason for that. So in this case, as we have for chlorine chloride solution reacting with potassium chloride, the reaction will not take place. Why? Because these are all chlorine reacting, or in this displacement reaction. So but if you have chloride solution reacting with potassium bromide, we shall have an orange solution in color, and this shows us the reaction has taken place. So we are going to see also that as we move also to the reaction of other salt with their elements, with the one of the halogens, we are going to see that when bromine water let me say here we have chlorine, chlorine water. We are going to have it reacting with, so chlorine water here, when it reacted with potassium iodide, we are going to see that the reaction turns to a brown solution, which is showing us that there is displacement of iodine. So there is displacement of iodine from potassium iodide, and this will show that iodine is formed. So this brown solution will be the solution of iodine that has been displaced from potassium iodide solution. So in this case, chlorine displaces iodine because iodine is the least reactive element in group 7. So also we are going to see that bromine water or bromine solution, which is orange. So we are going to have it reacting with potassium bromide, potassium chloride. Here we are going to say that there is no reaction. Why, learners? Because bromine comes after chlorine atom. So in this case, we shall say that no reaction that has proceeded. No reaction seen. Why? Because here we are going to have that the elements or the atoms, they are following each other in the reactions. So we are going to have also bromine with potassium bromide. We are going to say that there is no reaction also. Why? Because they are of the same atoms. So in this case, you cannot have bromine reacting with bromine, or bromine cannot displace bromine. In this case, we say that there is no reaction that has taken place. Also, we shall have bromine solution reacting with potassium bromide. So if you have bromine reacting with potassium bromide, then we shall have reaction that occur. Why? Because here bromine will take the place of iodine. So in this case, we shall have brown solution of bromine. So we shall have brown solution of iodine form. So learners, this is all showing how the displacement reaction takes place. So whenever we deal with the halogens, we need to remember the displacement reaction. We need to remember the reaction with the metals, or the metal wool, or the iron wool. And here we are going also to see that in the displacement reaction, the least reactive cannot displace the highly reactive. So what I mean is, when you have fluorine and then you have iodine, so iodine cannot displace fluorine from its compound, but fluorine can displace iodine from its compound. So as you have seen in these examples, that chlorine solution displaces iodine from iodide solution. Why? Because iodine is the least reactive compared to chlorine. So it means here we know that the 5 elements in group 7, they are starting with the fluorine and they ended with iodine or with astatine. But because astatine is a radioactive, we are not going to consider it. So we say it ended with iodine. So in this case, we say that fluorine displaces the rest of the elements in the group up to iodine. So in this case, we have seen them as we have seen in the reactions here. So also you have seen in the reaction of the metal ion. So iron wool, it also shows some reactions whereby there are crystals formed. So you need also to remember all those learners. So that whenever you deal with halogens, you know what is happening in halogens. And whenever you deal with any other group, you know what is happening in that group, their reactions, their physical properties. And here we say that in the physical properties, we have the electronegativity, the electron affinity, ionization energy. All these 3, they decreases as we go down the group. So you need to remember that the first element in group 7, which is fluorine, is having the highest ionization energy. the highest electronegativity, highest electron affinity, and also is highly reactive. And because it is highly reactive, which is fluorine atom is highly reactive, this makes it not to react in the same way as the rest of the element in the group. So with this, learners, we have come to the end of this lesson. So thank you very much for watching.